This is part 1 for the piecewise function notes. First of all, what is the definition of a piecewise function? A piecewise function is defined as by at least 2 equations or pieces, of each of which applies to a different part of the domain. So here are a couple of examples. So in this graph, we have 3 different equations that are being graphed. Notice that we have closed circles, and on some piecewise equations, when they are graphed, you might have some open circles. And we're going to talk about all of the different parts and the unique things that it takes to create these graphs. Each of these equations of piecewise functions have domain and ranges. First of all, domain is the set of all inputs for a function. Many functions have unrestricted domains, meaning the inputs can be any real number. Other times the domain is restricted, meaning there are limitations to what can be plugged into the function or used in the function. So again, domain is what we put in. So on the graph, this would be controlling the left and right boundaries for what we're graphing. There are 2 main ways to write domain for a function. We can have an inequality notation and an interval notation. And so these are some symbols that we use. Inequality notation uses symbols less than, greater than, less than or equal to, greater than or equal to. And you want to use less than or equal to or greater than or equal to when you want to actually include the endpoints, and less than or greater than when you don't want to include the endpoints. And so this is going to be where we use open and closed circles when we create the graph. Something that's new for us would be called interval notation. Interval notation uses brackets. Okay, so we use this hard left bracket or right bracket when you want to include the endpoints, and then soft parentheses when you don't want to include the endpoints. So here are a couple of examples when we're using interval and inequality notation. So on example 1, we want to write each of these in inequality notation and interval notation. So first of all, inequality notation, again, is those less than or equal to signs, and interval is with the brackets. So a function allows inputs from -7 to 10. So on a graph, the x-axis would span from -7 to 10. And notice here it says we want to actually include -7 and 10. So for inequality notation, we'd say -7 is less than or equal to x is less than or equal to 10. For interval notation, we'd have to use the hard brackets, -7, and then you just use a comma, 10, hard bracket. So this is not an ordered pair, but this is interval notation for the domain. On B, again, we're going to go from, here we go. On B, we're going to go from -7 to 10, but this time we don't want to include -7 or 10. So we're going to use the less than or equal to signs, less than, okay, so -7 is less than x is less than 10. And on the interval notation, it would be soft parenthesis -7, comma 10. And so then the third option here is going to show that we're going to include -7, but not the 10. And so that would look like -7 is less than or equal to x less than 10. Notice that these two signs are different, and that's how we distinguish between including the -7 or not. And then on the interval notation, we have the -7, comma 10, hard bracket here with the -7, soft parenthesis with the 10. All right, so let's move on to range. Okay, and range is the set of outputs for a function. The function's range always depends on its inputs. Just like for domain, ranges can be written as inequality notation and interval notation. All of those same rules and symbols apply, with being equal to or not equal to, including and not including. So on a graph, the range would be how far up the y-axis and how low on the y-axis the data would span. When we use domain, we were using x's. Now when we use range, we're going to use y's. So on A, it says the function can have outputs above 4, including 4. So the graph would just be above that 4. And so we would want to say, we have two options for this inequality notation. So we want to say that 4 is less than or equal to y, because we want all of those inputs above 4. And then we technically, we always want to write the variable first here. So we're going to say y is greater than or equal to 4. Okay, because we want all of the y's above 4. So we want the y's that are bigger than 4. Interval notation, we're going to say that we want to include the 4. And now this symbol here, it says that we're going on forever. So this is the infinity symbol. So it's just a sideways 8 is how I like to think of it when I want to write it myself. And then we have a soft bracket because you cannot ever equal infinity. It goes on forever, so you always have to have a soft bracket next to infinity. On B, this one is just slightly different. A function can have outputs above 4, but we don't want to include it this time. And so we would say that y, again, we want the y's to be bigger than 4. And then on interval notation, so that's not including the floor with the equal sign. Then on interval notation, we have soft bracket 4, comma, infinity, soft bracket. And as we go on and see some of these problems in context, they will make a little bit more sense. Okay. And the last two examples here, a function that has outputs from -2 to 15, not including -2, but I do want to include 15. And so with that being said, we would go from -2 less than y, less than or equal to 15. So my range here is trapped, so I have an upper and a lower boundary for the span of where I would have the data go from. And then on interval notation, I'd have soft bracket -2, comma 15 with the hard bracket because I want to include the 15. And then the last problem here, a function can have any output, meaning it can go forever all the way up and all the way down. And so for any inequality notation, we're just going to have to write the phrase all real numbers. Looks like I'm missing a L there. So it's all real numbers. And there's a symbol for all real numbers, and it's a double-sided R. So if you draw 2 bars and then draw a cursive R over it, that symbol there replaces these 3 words, all real numbers. So you can use either of the phrase or the symbol itself. And then for interval notation, it's saying we're going, again, soft brackets on both sides. We're going from -infinity all the way to infinity. So we're going to practice. This is just part 1 for Piecewise notes. I know I was trying to give you some visuals of what these look like on graphs, but we're really going to start digging into graphs and what they look like with Piecewise for day 2.